let's do problem 55 on page 102. Woohoo! All right. So I've set it up here, but let's read the problem anyway in the book. It says, an 18 kilogram box is released on a 37-degree incline and accelerates down the incline at 0.270 meters per second squared. Find the friction force impeding its motion, and how large is the coefficient of kinetic friction? All right. So let's solve it. Well, I want to know what the force of friction is, so I want forces. And I did step one, right? Step one of the 5-step procedure. Given, find, and solve, all looks good. Now, let's draw the crate again. Draw a free body diagram. Step two, draw the free body diagram. So I got mg, right? Gravity's pulling it down, and the incline is pushing up on it like this with the normal force. And then the incline is also impeding its motion with the force of friction like this. And that's what I'm trying to find, is that force of friction. And is there anybody pushing or pulling on this? Is there a rope or a person or anything pushing on it? No. So it's a pretty easy well, a little simpler. There's no applied force. There's no pulling force or pushing force. So that's it. So let's make down the incline positive x. Normal to the incline is positive y. And so we'll take the force of gravity and break it up into its x and y components. So that's mg cosine theta, mg sine theta, as usual, right? So I completed step three. I identified my x and y axis, and I looked at all my forces. This is in the x, this is in the y, but this is in the x and the y, so we have to resolve it into its x and y components. Now I can do step four. Oops. Let's do x first. Let's sum the forces in the x direction equals ma in the x direction. I underline it, and I do the work under here. I look in the x direction. What have I got? In the positive x direction, I've got mg sine theta. In the negative x direction, I've got the force of friction. Equals, do I have acceleration? Yes. So I can't make it 0. So now I can solve for the force of friction. The force of friction, I'm going to add it to this side and subtract the other way, is equal to mg sine theta minus ma. Did I do that right? Yeah. Now I can plug in my values. Well, the mass, oh, did I put the mass on there? It's 18 kilograms. I didn't put it in the given. So, this is 18 kilograms. You can factor this out, it makes the math a little bit faster. 9.8 newtons of force per kilogram of mass times the sine of 37 degrees minus 18 kilograms times the given acceleration is 0.27 meters per second squared. Now I get my calculator out. Where'd my calculator go? There it is. So 18 times 9.8 times the sine of 37 degrees equals 106.2. And then from that, I'm going to subtract 18 times 0.270, and I get 101.3 newtons, or just 101. And I'm done with part A. On part B, I want the coefficient of kinetic friction, and that's equal to the force of friction divided by the normal force. Well, I know what the friction is, but now I need to know what the normal force is. Sum of the forces in the y direction equals ma in the y. And I've got the normal force minus mg cosine theta. There are no other forces in the y direction, and there is no acceleration in a direction perpendicular to the incline. So it's equal to 0. So the normal force is equal to mg cosine theta. And so that normal force, 101.3 newtons. And then this is, what is this? This is 18 times 9.8 times the cosine of 37, 140.9 newtons. And I get 0.719. I'm not done yet. Okay, so that looks pretty good to me. I don't see any mistakes, but there could be, so I'm going to check my answers in the back of the book. So this is chapter 4, number 55. And it says the force of friction is 101 newtons. And the coefficient of friction is 0.719. So I take out my red pen. And I put stars on it because I did it right. Star and question mark your work as you go. All right? Like what I just did right there. That is all.